Scientists have reported on some unusual things flying into space recently. In one paper, sperm stored aboard the International Space Station for the last 5 years has been brought back to Earth and been used to fertilise eggs. The aim was to assess its viability. But also, late last week, a consignment of glow-in-the-dark bobtailed squid also headed spacewards to look at how microgravity affects the relationship between host animals and the microbes they carry on and in them. Westminster University astrobiologist Lewis Dartnell talked me through the different projects.
The researchers in this case are looking into the potential for preserving sperm in the interests of space travel, of space exploration. And they took some mouse sperm and they have freeze dried it, which is the same process you do for effectively instant coffee. They've created some instant sperm and they've launched that up to the International Space Station and then left it there. And this latest paper is the result of 5 years of exposure to the space environment on the International Space Station. And they've brought that instant sperm sample back down to the Earth, rehydrated it, mixed with a bit of water like you would with instant coffee, and now have demonstrated they can successfully fertilize mouse eggs, which had stayed on the ground, to produce healthy mouse pups. And indeed, they show that the next generation is perfectly healthy as well. So the conclusion from this result is that sperm can be successfully stored in space by freeze drying it for at least 5 years.
I learned something very interesting when I read the paper in which they document this, because they
Yeah.
say the current NASA space radiation cancer risk model is built largely based on epidemiological data from the survivors of the Hiroshima and Nagasaki atomic bombings, but not from real experiments in space. So I suppose they're closing the gap with that. They're basically saying we were using the best proxy we had for radiation exposure on tissues like people's sperm-producing tissue. And actually we're going a step further now and actually testing the real deal.
Yeah, this is one of the main hazards of space exploration for humans is the very energetic radiation particles in outer space, things spat out by solar flares or really energetic particles accelerated by things like supernovae, by exploding stars across the galaxy. And this kind of radiation is very hard to recreate on the ground using things like particle accelerators or radioactivity. So the best way of studying what space radiation does to the sort of tissues and organisms you're interested in is to launch them into space and observe them over many years to see what happens. The idea is that in the future, when perhaps we start trying to settle and colonize Mars and maybe want to start taking livestock with us, to not just have a totally vegetarian diet for Martian colonists, but maybe take some chickens, maybe some pigs, is that you don't have to now start putting living animals into crates aboard the spaceship. You just send the freeze-dried sperm and then a couple of females to fertilize when you get there. And I guess in the very long term, rather than talking about generation ships and sending large populations of humans across interstellar distances to try to colonize other solar systems, this is one of the early steps in research that's necessary to look about whether you could send just the human gametes, just send sperm and maybe artificial wombs or something.
The other thing that was shot up to the International Space Station in the last week or so was samples of squid. The claim from NASA is they're interested in looking at the relationship between these squid that glow and the bacteria that make them glow. So why is that important?
Yeah, these bobtail squid are really, really interesting creatures, and they are masters of disguise and camouflage and communication. And they use glow-in-the-dark, bioluminescent bacteria, that they have this symbiotic relationship between the animal, between the squid and the bacteria, to get the bacteria to create light for them, which they use in helping in their camouflage and in signaling to other squid. So although we're not directly interested in glow-in-the-dark squid in outer space, although there is a cracking series of sci-fi novels by Stephen Baxter where intelligent squid are used in space exploration out to the asteroid belt, but what they are being used for is a great model organism, a great example of the interaction between animal cells and animal tissues and bacteria. and how the microgravity, the weightlessness environment of outer space, affects that close interaction. So we can then apply the squid results to human studies, to human understanding.
Do they anticipate there being any changes or differences?
Well, the data we have already indicates that the interaction between humans and bad bacteria, the bacteria that give you infections and germs, is made worse. Something about the space environment seems to make bacteria more virulent. And so this kind of research, looking into the general cell science, the general goings on of that interaction between bacteria and animal cells, will help our understanding.
They also sent tardigrades, didn't they? These are also known as water bears,
Mm.
and they look grotesque. These
They look cute.
they're
What do you want about,
microscopic
Chris?
organisms.
These are cuddly microscopic little bears.
But they are also hard as nails, aren't they? I mean, these things can survive being physically in space. No spacesuit. These organisms survive that. What are they hoping to learn that they haven't done already?
Yeah, so tardigrades are kind of commonplace. Like if you were to go out into your back garden or out into a park and find a shaded, damp, mossy area, it will be teeming, absolutely crawling with these tiny little microscopic tardigrades. But when the going starts getting a bit tough, if it starts getting cold or it starts drying out, these tardigrades roll up into a little ball, dry themselves out, and turn into what's known as the tun state, TUN. And in that tun state, they are incredibly hardy. They can survive very high doses of ionizing radiation, of the vacuum and cold of outer space. They're also, therefore, a really good model organism for studying the survival of life in very extreme environments. And so there's been a whole series of experiments now looking into tardigrades and other extremophiles, other ultra hardy organisms, to try to understand how they can tolerate and survive these very, very nasty, hostile conditions. And a lot of this research links then very directly into my own field of astrobiology and the possibility of life on Mars and how life survives this cosmic radiation that we've mentioned already. And tardigrades feature quite heavily in that sort of extremophile research.
Lewis Dartnell,